Great. So thank you, Athar, who's working in the background, and he'll come on later. Well, so a very good Sunday morning to you all in India. And if you're joining in from other places in the world, take my greetings according to your time zone right now. I'm Samir Dhurde, welcoming you to this awesome astronomy series, especially for amateur astronomers who are really awesome people because they are able to juggle their daily life and put in a lot of astronomy in there as well. Of course, professionals do it all the time, but you guys are the ones who really find that time, make that time for this hobby or your passion, basically. So we thought that in this series from the Inter-University Center for Astronomy and Astrophysics, we'll introduce you to more serious efforts in actually creating some kind of scientific contribution with the efforts of the amateur astronomers across the world. And we've already had two lectures, two talks, interactions rather, with very friendly people from the Panoptus team and the AAVSO team. And it's a pleasure to have the IOTA team here today. In fact, Ted Blank is leading the talk today, interaction today. And this will be about occultations. So yes, it's close to Halloween, which is more of an American celebration of the occult and the dead and souls, etc. So let's have it. There's no relation between this. We, of course, had Dark Matter Day yesterday. All of these have coincidentally come together at the same time. So IUCA has been running a lot of activities for amateur astronomers locally, and we thought we would expand it to a larger audience now that we've been restricted to our houses with the COVID situation. India is still sort of under lockdown, although people don't seem to be caring so much. Officially, we are. And hopefully, you all will be safe and stay safe and stay cautious until the whole second wave, as it may be coming, is over. So what better to do but take your telescope upstairs, your roof, or a safe place and observe during the evenings as a pastime. So if you want to contribute more and if you want to know how you can do that, this is the series you should follow. And we'll have many more events following in the following series where you'll either get connected with the experts from various fields, or we'll also discuss some activities we can do together with the IUCA experts here. So I also have today in the speakers, Mr. Arvind Paranjpe, and he's IUCA, he's one of the founder members of the IUCA outreach program, and he's definitely the founder of the MVISA activity. However, he has shifted from IUCA to the Mumbai Planetarium and is the director there for almost a decade now. So Arvind, I will actually request you to say a few words just to start off the program and also to welcome Ted to the interaction.
Yeah, good morning, everybody, and good morning, Ted and Samir. Just a few notes on occultations in India. It was started at the Indian Institute of Astrophysics by its earlier director, Professor J.C. Bhattacharya. And the team was involved in discovery of rings of Uranus. But as an amateur astronomer at that time, that was about 1979, 80s, I got quite excited about it and I started observing occultations. Not too many, but yes, I got excited about it and participated in observations of few occultations. We also observed one, after I shifted to Pune at IUCA, we had taken a team which observed occultation of asteroid Diotima. I think it is 423 Diotima, and which eventually converted into a paper. So a paper was published using that. We also made a few efforts, but it stopped at that. for various reasons, because as an outreach officer, and Samir knows it very well, the kind of tensions that we go through trying to manage. So it stopped at that. Even at Mumbai, we started this occultation observations, but the distances are too large. Anyway, the transport was not so easy, and the telescope is kept right in the middle of the city where it's a lot of light pollution. Having said that, I would just add a couple of things more, and that is we had a wonderful time, Samir and another M-Visa student. And when we actually observed ingress and egress of Mars, right from where Samir is sitting on the top of the building, and we saw Mars going behind the moon and then coming out, it was an excitement. I have always enjoyed, I don't know how many occultations I have observed, not reported too many, but every time that excitement brings that blood rushing and adrenaline rushing through the body, and you're waiting for it, and then you time it, and it's always has been enjoyable experiment. And I should not be saying we are talking about too much, but that Ted would do. But I would also say that after this talk, with Samir leading the IOTA and the amateur activity, I think we should get into this occultation a little bit more seriously, whether visually timing it or with the instrumenting, recording it with an instrument. And there's a good lot of history. I mean, right from, I think I remember McMahon saying that you can use occultation to find the angular sizes of stars. And then Arthur Eddington killing it down, and then people from Australia actually recording these occultations. So we will come back to the history of it at some point in time. I would really enjoy talking about the history at some point in time, but let us get on with the job that we have on our hands. So Samir, you can invite, unmute Ted, and let's go ahead with it. I'm equally eager to listen to him, actually.
Yes, of course. Thank you very much, Arvind, for that recalling of activities here. And yes, it is always exciting. And I remember, it's another good thing about astronomy is that we get to go to these exotic places for observations, because it's not always happening. The event is not always happening at your roof. You have to travel and go. So there's also a fun journey. So I'm looking forward to hearing from Ted about all his exciting activities, his journeys, his experiences across the world, both for work and both for his passion of astronomy and occultations. So Ted has been at the International Occultation Timing Association for 10 years now. And he, as he says, he enjoys the challenge of chasing the shadows of particularly of asteroids. So let us start with our passionate sidewalk astronomer, as he calls himself. And let's all listen to what Ted has to tell us about occultations and the IOTA as well.
Oh, well, thank you, Samir. And Arvind, thank you both. I appreciate being here. It's really nice to have the opportunity to talk about something that I enjoy. I have been doing this about 10 years. It also includes some time as a NASA Solar System Ambassador. Solar System Ambassadors are volunteers who give talks on solar system exploration and the various missions that are going around the solar system. So I do some of that as well, but I also enjoy traveling for the occultations. I know that my colleague Paul Maley has been to India many times and has given training and led expeditions around India for occultations. So I want to give Paul full credit for really kicking this project off in India, and I'm happy to talk about a little bit about the details and answer any questions that anyone might have. I have a presentation that I'll offer for you today. There are some slides, some videos. I hope it's educational and interesting, and I'll be happy to take any questions along the way in the chat room or however you want to ask them, and we'll have a good discussion. So I'll share my screen now. And
I'll just take that moment to ask all the participants to send their questions to me, because Ted will be giving the talk. Just
very good.
Chat and we'll take care. Thank you.
That will work very well. Okay. So hopefully you can all see the screen okay, the presentation. Good. Okay, great. So I call this Chasing Shadows. This is an opportunity to do real solar system science with amateur equipment and without a whole lot of investment and without a PhD as well. I have a master's degree in biology, so astronomy is very much a side passion for me, but one that I really, really enjoy a lot. My email is here if anybody has any questions they want to ask me offline or send any notes or interesting information, please feel free to do that. So let's just start by talking a little bit about the geometry of what we call an occultation. And in this case, we'll start with an asteroid occultation. This is a way to study these objects without launching a billion-dollar space mission into space and spending a lot of money. What we've got here is several objects on the screen. Way over on the left you see a star, which is really far away. And then next to that there's an asteroid, and then which is a lot closer to Earth, of course, than the star is. And then here on Earth we have multiple observers labeled A, B, C, D, and E. These are people with telescopes, and they're pointing their telescope at this star. And so what we're expecting to happen is the asteroid, as it moves through its orbit around the sun, will, we hope, pass right in front of the star, and then the shadow of the asteroid will pass, of course, right across the planet Earth. If we are in the right place at night and the sky is clear and the moon is not out and lots of things go right, we might be able to observe the star disappearing behind the asteroid in real time. One interesting fact that I always like to point out is that the shadow of the asteroid on the Earth is the same shape and size as the asteroid itself in space. Because the star is so far away, the light rays from the star are essentially traveling in straight lines. So if the asteroid is a 20-kilometer circle, it casts a 20-kilometer circular shadow on the Earth. And the observers will see the star pass behind different parts of the asteroid depending on where they are on the surface of the Earth in the shadow. And as you see here, the definition, an occultation is simply one object passing in front of another. So in this case, the asteroid is said to occult the star. And even though it's Halloween here, this has nothing to do with occult or witches or anything else like that. So down in the lower left corner now, here you can see what those 5 observers might have seen in an event like this. Observers A and E would be outside the shadow, and they would see the star continuously shine without disappearing. But observers B and C and D, if they were lucky like this, would be in the shadow, and they would see the star disappear. Now, observer C would see the star disappear for the longest amount of time because that observer would see the star pass behind the widest part of this imaginary asteroid on this diagram. Whereas observers B and D would see the star disappear for slightly shorter amounts of time. And an observer who saw the star pass behind the very tip of the asteroid might actually see a very, very short occultation. But each of those observations measures the diameter of the asteroid across that chord across the body of the asteroid. So this is how we obtain information about the three-dimensional shape of the asteroid by looking at its two-dimensional projection against the sky. So a little bit about IOTA. IOTA stands for International Occultation Timing Association, because our main mission is to accurately time these events. And these are some of the missions that we have taken on. We make the predictions for these occultations of stars by asteroids, planets, and the moon. And that requires some of our members to periodically, every month, calculate possible occultations for all of the visible asteroids against all of the visible stars. And as you can imagine, that's quite a large combination. So in the end, we take those that large number of predictions, and we provide some software that I'll talk about later on that you can use to filter that large list down to the ones that might be happening somewhere near you. We also provide training to help people observe and measure these events. We provide free software and information on equipment and techniques, and we even have some equipment for sale to make sure that people can start this hobby at a reasonable cost. And of course, we do publish our results in the Journal of Occultation Astronomy and the Journal of Double Stars, and all of our data is archived in the Minor Planet Center. So we have thousands and thousands of asteroid occultation observations and double star observations and double star discoveries that are archived for professional scientists to use to study these objects. Now, asteroids, as I'm sure most of you know, they mostly reside in something called the main belt of asteroids, which is between the orbits of Mars and Jupiter. There's that big empty space where it's possible that a protoplanet might have been trying to form there and was destroyed or collided or failed to form because of Jupiter's gravity. Lots of different theories about why the asteroid belt exists so close to Jupiter, but we're pretty sure it has something to do with Jupiter being the big bully in the solar system as far as gravity goes. So these asteroids have been around since the formation of the solar system. And so studying the asteroids gives us a window into the time during which the solar system was forming and the time when the planets were forming. So when we study that formation, we're able to also study to anticipate what might be happening in other solar systems around other stars where exoplanets are forming or may have formed already. And this informs our education about what to look for when we're looking for planets around other stars as well. The solar system is a big place, and even though there are lots of asteroids, they're quite far apart. And so there's no need to dodge asteroids if you're driving your spaceship through the asteroid belt. And in fact, about a third of the entire mass of the asteroid belt is contained in a single asteroid called Ceres, as you see down here, CERES. So it's pretty empty, even though it's populated with millions of these tiny rocky bodies. In India, I'm pleased to point out that you have some very dedicated amateurs there who have provided you with these many resources that make it easy to get started. There's IOTA India section with its own website that has a lot of information about getting started with occultation observing. There's also information about equipment, results of recent observations, information about how to talk to folks who are also interested in it in your area, and so on. In addition to the website, there's also a Facebook group, Occultations in India, where events of interest are posted by one of our speakers at our last at least some of them by Suhas Gurjar, one of our speakers at our last IOTA meeting as well. You see some of the information that he's posted here in this slide. And worldwide, there's a discussion group called IOTA Occultations. Up until last year, it was hosted on Yahoo, but because of Yahoo's termination of the groups project, we've switched to, as many of our brethren have done, to this group called groups.io. So we are now IOTA Occultations at groups.io. This is a free service. We encourage everyone to subscribe to this discussion. We have on here discussions of equipment, of upcoming events, results of recent observations, planning for upcoming meetings when we can have those again, and so on. That's at groups.io. So I live in the area near Phoenix, Arizona, in the southwest part of the United States. And sometimes we get lucky here and these shadows pass overhead fairly close to us. In this case, my house is at the small red star, and we have about 6 observers who happen to live within 20 or 30 miles of me here, and we usually cooperate when an asteroid shadow is predicted to pass over our area. In this case, this asteroid shadow, I have a little animation here, it was scheduled to pass right over the Phoenix area like this, about that size. And we were hoping that we would be lucky enough to be in the shadow. So some of us have enough equipment that we can go out and set multiple telescopes out in the field. So I decided to do that for this particular event, which was for the asteroid Thyra. I decided to try to put out either 5 or 6 small telescopes on a road that crossed the area that the asteroid shadow was going to pass across. This whole road would have taken me about 1 hour to drive. So I loaded up my car with some equipment that you can see here. These are small 80 millimeter telescopes. Each one of them is on a small equatorial mount. No motors or electronics. And each of them sits upon a tripod that I purchased from a company that makes lawn sprinklers. So everything was put together in the workshop. In the upper right, you can see some batteries and some cameras. Each little bucket goes with one of these telescopes. And then I drove out into the desert and found 5 or 6 places where it would be safe to leave one of these little telescopes alone in the dark. And then I pointed them to the place in the sky where the occultation was predicted to occur. Started the timer and then drove off and tried to do that for the next one as well. This is something that I like doing. I do like doing mobile occultations, but it's also quite acceptable to simply set up a telescope in one place and simply sit there and wait for the event to occur as well. And this is how most people get started. So what does one of these look like? As Arvind said, it's pretty exciting to see one of these. So here's a little video of what it looks like when you are looking at a star and an asteroid passes in front of it. Keep your eye on that star in the red circle. And we'll let this play several times. What's happening here is that as the Earth is turning, it's causing these stars to drift across the field of view of the telescope. And out in space, an asteroid is getting closer and closer to the star, and then all of a sudden the asteroid edge passes in front of the star, and the starlight immediately disappears. And then when the asteroid passes in front of the star and uncovers it, the starlight reappears again. Now, I don't know if you can see this, but in this case, the asteroid is quite large and quite bright. And so you might even be able to see during the time when the starlight disappears, you can see a small dot in the same place. That's actually the asteroid. And it's pretty unusual to be able to see the asteroid because normally they're much fainter than the star. And the good thing about getting started in occultations is you don't need to be able to see the asteroid in your telescope. That would require a really large aperture telescope. You only need to be able to see the star before it disappears and after it reappears. That's the key to the whole science. So when we put together the information about all these disappearances and reappearances from all of the observers, we get a picture like this. This separation of these lines, north to south, represents the position of all the observers on the face of the Earth. Some of them are farther north and some of them are farther south. These empty spaces in the middle represent the amount of time that that observer saw the star disappear. That is the measure of the diameter of the asteroid along that chord across the asteroid's body. And when we combine all of those together, we get an estimate of the size and shape of the asteroid as it's projected against the sky at that moment. Of course, asteroids are different shapes, and they rotate at different speeds, and they can present different cross sections to us. In some cases, there's even one asteroid called Cleopatra that looks like a dog bone. So sometimes it's quite wide, and then if it's end on, it's very small. This case, the asteroid is a fairly common elliptical shape, and you can see here this is not a particularly good match to this model of the asteroid, which is created from a group in Czechoslovakia, but it does give them some feedback as to whether their model is an accurate estimate of the size and shape of the asteroid. There's another asteroid called a binary asteroid, two rocket bodies that orbit each other. It's called Antiope. And as you can see in the upper left corner here, our best picture of Antiope from Earth was taken from the Keck telescope using adaptive optics. And essentially, you can see these two orange-colored dots that give us the idea of where these bodies are in their orbit around their common center of gravity, but not much detail about their shapes and sizes. And so IOTA chose in 2011, it was predicted that these two bodies would pass in front of a bright star and that it would be visible, the occultation would be visible in California. And so IOTA decided to have our annual meeting in California and then to spread out and set out as many telescopes as we could to get a very good image of this asteroid's occultation. You can see up here in the left corner, as I mentioned, this is the best image that we had of the asteroid's bodies until this occultation. Now, what I have next is a little movie or an animation. It has little blue dots on it, and each dot represents one of the observers. And I have created the animation so that the blue dots disappear when that person saw the star disappear, and they reappear when that person saw the star reappear. And I've also added to the animation a couple of circles that I think represent where the shadows were as they passed across the Earth. So we'll play that little movie for you right now. Here in the upper right, you can see one of the shadows approaching some of our observers. And when the blue dot disappears, that's when that observer saw the star disappear behind the body of the asteroid. There are two asteroid bodies here. This is a binary asteroid system. So if you watch this, you can actually see how these rocks in space cause the star to disappear at different times for the different observers. So that movie is at about 3 times the actual speed. So the entire event took about 2 minutes. And at the end of that time, we all gathered back in our central location and took a look at our data, extracted all the times from the recordings, and the result looked like this. So you can see the benefit of having a larger number of observers, because we were able to measure this each of these asteroid components at several dozen locations. The result is that we get an accuracy of plus or minus about 1 kilometer at a distance of 400 million kilometers. There's no way to do that without launching a spaceship to the asteroid to take pictures of it close up. But we can do it here on Earth with small telescopes. In fact, this star was so bright that we were able to do this entire measurement with telescopes that had just 50 millimeter aperture. Each one of these telescopes was a half of a pair of binoculars. That's all it took for this particular event. And you'll notice on the lower component, we were actually able to measure and characterize this giant crater that looks like, let's see if we can, we have a little, yeah, I guess I can't really write on here. But you can see that crater. It looks a little bit like Pac-Man. No one knew, of course, that this component had this giant collisional crater on it, but we were able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or 11 measurements of its depth and size and shape, characterizing the surface of a body that's 400 million miles away, 400 million kilometers away, and almost completely invisible to the naked eye. One of the other things that occultations can provide is the identification of satellites. Some asteroids actually do have satellites, and in this case, my colleague Steve Kennard was observing an occultation by this asteroid Agamemnon, and in the center you see the large dip where the asteroid main body went in front of the star, but then circled in red about some number of seconds later, a small dip that represents a satellite, a moon of this asteroid that happened to be following it exactly in the right place so that it also occulted the same star, but slightly later. So Steve was able to confirm the existence of a satellite around an asteroid by just being luckily in the right place at the right time and making this observation. Another interesting result from 2013 was the identification of an asteroid that had rings around it. Some of you probably remember this. It's called Chariklo, and the observation was done in the southern hemisphere. Here in the middle, you can see the occultation of the main body, by the main body of the asteroid, but then preceding it and following it, these two occultations or partial occultations showing that there are rings around the asteroid, and in fact those rings have some structure. You can see that there are two occultations in each of these dips, representing some sort of a double ring around an asteroid, again, that's hundreds of millions of kilometers away, and there would be no way to make this kind of observation except by sending a spaceship out there at great cost. So that's pretty exciting stuff. One of the other things that occultations are good for is to investigate and possibly identify double stars. In this case, we've got the moon, almost full, but not quite. You can see the terminator, and then that blue curved line represents the leading edge of the moon, which is dark and invisible. The moon is moving from right to left, and this little dot is suspected to be a double star. How could we tell it's a double star? Well, in the case of its light curve, if you look in the lower right corner, in this case, the starlight actually disappeared in 2 steps. When the leading edge of the moon occulted the first component of this binary star system, about 2/3 of the light disappeared. And when about 0.6 seconds later, it occulted the second component, the remaining 1/3 of the light disappeared. And so we were able to publish a paper identifying this star as a previously unknown double star. This was actually my first positive occultation. This is almost 11 years ago. And my light curve is the second one from the top here. It's not as good quality as the one at the top, but you can barely see that there's a 2-step disappearance of the light curve. And that's a confirmation of the fact that this is actually a double star. So that was pretty exciting for a beginner. You never know what's going to happen. At the moment, several of us involved in IOTA are assisting NASA and the Southwest Research Institute in a project called the Lucy mission. Next year, the Lucy mission will launch and begin to investigate take close-up images and study 6 asteroids in what are called the Trojan groups of asteroids. The Trojan asteroids are the ones in green here, and they are at the 2 Lagrange points. They precede and follow Jupiter in its orbit around the Sun. They've managed to find places where there's a gravitational resonance, and they can stay safely ahead of Jupiter or behind it. And so Lucy is going to follow this red path, and it's going to visit 6 of these asteroids over the course of a 14-year mission, starting in 2021. So anytime one of these 6 asteroids passes in front of a star and there's a predicted occultation, the folks at the Southwest Research Institute decide if it's worth it, and if it is, if the prediction is good and the shadow is passing someplace that we can reasonably get to, they'll send us to exotic places like South Africa or Argentina, or even more exotic places like Texas. And we'll bring along large telescopes and we'll record these occultations. The data helps the scientists then understand more about the size and shape of the asteroid, and particularly it helps them understand more about its orbital parameters so that they can more accurately target the spacecraft to pass as close as possible to the asteroid to get the best possible pictures and data on the asteroid. This mission will not go into orbit around any of these asteroids. They will all be flybys. So it's really important that they be able to fly as close as possible and know exactly where the asteroid is so they can take these images, because all of the pictures will have to be taken autonomously by the spacecraft without any help from anybody here on Earth. So a little bit about the hardware. This little box is called the IOTA Video Time Inserter, or VTI, and it contains a GPS chip and some special hardware and software to place an accurate GPS timestamp on every frame of a video. You can send an NTSC or a PAL video through this box, and what will come out is the same video with a timestamp on the bottom. You probably remember seeing those timestamps on the bottom of the Thyra video that I showed earlier. So here's a little diagram of what the connections might look like for something like this. It looks like a big mess, but it's pretty simple. You'd start out with a telescope up here in the upper left, and you would place this little camera or one like it into the focuser of the telescope, probably with a focal reducer on it as well. This is cameras made by RunCam, a Chinese company that makes cameras for drones. It's extremely sensitive, black and white, low light camera, and we found that it's the cheapest way to get started in occultations, because it provides really good quality results at a very, very low price. And so we sell these cameras with a special set of firmware in them that actually further increases their sensitivity. RunCam was willing to make some changes to their software in the camera for IOTA. So then the output of that camera would be sent into the video time inserter box, and what would come out of the box would be the same video, but now with a timestamp on every frame. And then that would be sent into a computer, usually a small laptop in the field or a desktop machine in your home base, with a digital frame grabber, some sort of a video capture device. And at that point you have a regular AVI video that can be analyzed in some of the software that IOTA provides also for free. Here's a picture of what some of that software results would look like. This is an analysis of each frame of a video, showing a very long occultation by a Kuiper belt object called Ixion that happened about a month ago. And in this case, normally we would see the star disappear instantly behind an asteroid or the edge of the moon. But in this case, the star actually has a significant diameter to it. So you can see here on the left and on the right, it takes quite a few frames of video for the starlight to completely disappear. And we're actually able to make a measurement of the diameter of the star using this technique. This was a very long occultation. The asteroid was traveling very slowly with respect to the star, and this event took, in my backyard, the star disappeared for over 40 seconds, which is the longest occultation I've ever been able to record. Typically they are 1 to 5 seconds at the most, but in this case we had a large object traveling very slowly with respect to the star, and the shadow was traveling quite slowly across Earth, so we had a very, very long occultation. This one was 44 seconds for me. We also provide the software that will allow you to determine whether there are any good candidate occultations that might be happening near you. This is called Occult Watcher. It's another free piece of software, and you can provide filters. You can set up filters on Occult Watcher, and you can say, I'm willing to travel 100 kilometers. My telescope can see stars down to magnitude 10, 11, 12, whatever the answer is. And Occult Watcher will go through all the thousands and thousands of predictions around the whole world and filter out only the ones that match your requirements. So you can then select one of those, and you can tell the rest of the observing community by putting one of these little telescopes on the map that this is where I plan to observe. So other observers who are looking for a place to observe can pick a different location and spread out across the shadow to get as good coverage as possible without everyone possibly being on the same chord. And you can see in this case we've got 6 total observers who have signed up for this event, which is next Tuesday, November 10th. And 5 of those observers are here in the Phoenix area, but there's someone else over here in Oklahoma, I think. So Occult Watcher works worldwide, and we've had many events where there are observers in Europe in the early evening, and that shadow will come across the Atlantic Ocean, and we'll have observers in the United States in the early, just before sunrise, observe the same event. So I don't think it could be nighttime both in India and in Arizona at the same time. We're 12 hours apart, but certainly in India and in Eastern Europe, there could be observers who could share the same event. So on the website, IOTA makes it possible to purchase this equipment from us, just to make it as easy as possible for observers to get started. We have cameras, we have the VTIs, we also sell a complete observing kit with everything you need except a telescope and some batteries to power everything up. And we're in the process of developing a design for a less expensive video time inserter based upon the Arduino system that we hope will be successful. I have one in my office now, and we're working on how to mass manufacture those as well. We want to get as many people interested and involved as possible. And as I mentioned, a giant aperture telescope is not required. The asteroid might be very, very faint, magnitude 18, 19, 20. It doesn't matter. All that matters is that you'll be able to see the star before it disappears and after it reappears. So small telescopes are quite sufficient if the star is bright enough to be able to see. Now, there aren't as many bright star occultations as there are dim star occultations, but there are quite a few, and the larger your telescope aperture, the more likely you are to be able to find an event close to you, in any particular week or month. So I've finished my discussion here. So in summary, if you have a telescope and you want to do some real science with it, please consider joining us as we chase these shadows around the world. I've listed here the references I talked about earlier, IOTA India section website, Facebook group, the discussion group, the occultations.org website, another website that has some information on it, asteroidoccultation.com, and my email in case anyone would like to get in touch with me. So I thank you for your time here. I'm going to stop the sharing, and then we'll see how things go if we have questions.
Yes, so thank you for that lovely talk and showing us those amazing examples of what individuals across a line of path of shadow can really contribute to, giving us the shape of the asteroid. In fact, that was one of the questions which was being asked, that, the biggest telescopes in the world, you don't have enough resolution to actually image the asteroids very well. How can you do it with small telescopes? This is the power of collective effort, and very much like having a huge telescope across states. And if the Indians join together, you could have something across the whole country. if the shadow is basically going over that. Shadow may not be that big, so that's another thing to keep in mind. So a lot of questions from our enthusiastic audience here. We had about 60 people watching live, and there are more.
Oh, great.
YouTube. So they want to basically ask a lot of questions about occultations. I'm just going to read them and pass them on to you.
Okay.
So, of course, many are interested in observing these. So one of the question is that how do you basically join such a group where you can do occultation observations? And what is the kind of equipment required? I think you've answered some of this in your talk, but just
sure.
Point out.
So the equipment is whatever telescope you have. It can be a telescope with a motorized computer, or it can be a telescope like a Dobsonian scope where you just point it. There are techniques for pointing your telescope to the place in the sky where the occultation will occur, and we can show you how to do that as well. There are some videos on our website about how to create what we call pre-point charts. Mm-hmm. So you would point your telescope to a star, to a place in the sky where the occultation star will be at a later time, and just leave your telescope alone and let the Earth turn the telescope to the right place at the right time. That's the easiest way to do this. The equipment, we would, if you already have a video camera that can be inserted into your telescope, you're ahead of the game. If not, the RunCam video camera is quite inexpensive. I think we sell it for $79. And a little more if you want the extra adapters and the focal reducer and so on. So we tried to. Many of the cameras that are not even as sensitive as that they sell for $600 or $700, and we realized that's not an entry level cost for anybody. But when we found this little RunCam camera that's designed to fly around in a drone, and saw how sensitive it was, we worked with them. So we've sold more than 100 of these over the last 3 years. They all come right out of my office here, and we package them up, install, make sure the right firmware is installed, and send them out. As far as finding an occultation where that might be one that you would want to do, let me share my screen again here and show you the program that I mentioned called Occult Watcher. Right here, yeah, here it is. So this is the Occult Watcher screen. It lists all the occultation events that are coming up in the next month or two, and the configuration allows me to filter out the events that I don't want to see. So I can say don't show me events that are too far away, that are too faint, that are too low, that are too small, etc. And so that filter is applied, and then only the ones that show up on the list are the ones that pass all those filters. So next week, here's that Bathilda event. It will happen at 9:16 Universal Time, or about 2 in the morning here. The combined magnitude is 10.4, which is fairly bright, and the magnitude will drop by almost 2 magnitudes during the event. And it is expected to last a maximum of 5.5 seconds. You can see that down here on the bottom. And if I want to see where all of my fellow observers are, I can bring up a map, and we can now see where everybody's planning to be. So we can spread out across the entire event. And then here you can see, again, that if we zoom out enough to get all the way over here to Oklahoma, here's my friend Steve Messner, who's going to be in Oklahoma. Oh my God, 1,000 miles away from me. But it doesn't matter how far away they are, because everybody will have the GPS timing on their video. So it's possible afterwards to combine everybody's data on a common time base that allows us to use this data together. So this is available. This software is available on the IOTA occultations.org website. You can download it there, install it. We have some videos on our website on how to use it, and it also, it'll work anywhere in the world. You just have to tell it where you live and what the limits are on what kinds of stars you think you can see, how bright they have to be.
Great. Arvind, do you have something to add?
Yeah. We have also tried, our first set of occultation is to use the web cameras, remove the lens, and then attach an adapter which goes, I think one of this IOTA also, someone had done that. That Philips camera, web camera gets directly attached. So if anyone here who would like to do that, maybe you can also buy the cost of these cameras could be something like 2,000, 2,500 rupees. And you can easily reach to 6th to 7th magnitude with the proper alignment. So you could do that to begin with. If you don't want to import, or you can try your hand at the first level.
Sure, we should. So basically up to your choice whether go for ready-made equipment, or you try something called Jugaad in India. So you make your own equipment, and that's the fun of it. It's all putting together whatever is needed for the purpose of occultations. I think the IOTA India team also has support and participation from various kinds of people, including engineers, electronics engineers, and people from manufacturing field as well.
Right.
So if you join such groups, you can put out your requirements, and probably you all can come up with solutions. So another thing that I want to point out is that amateur astronomy also works well if you work in groups. So definitely you should not just be lonely and join a group for some better observations in the future.
Agreed.
Some questions. Yash Agarwal is an enthusiastic student. He's asking about occultations, really. So by how much could he miss an occultation? If how much distance could one miss an occultation, given that there might be some inaccuracy in predictions?
Yeah, very good question. Let me bring up the Occultation, the Occult Watcher program again, and share that with you, because the answer is here in this on the screen. For this event, Bathilda, I'll bring up the map again. There are different colored lines on the map. The green line represents this, where we think the center of the shadow will pass, and the blue lines represent the edges of the asteroid's size if it goes right down the green line, dead center. But it almost never does. So the question is, how much uncertainty is there in this prediction? And these red lines give us that uncertainty. The first red lines, closest to the blue lines, tell you that there's a 66% chance that the shadow will be inside these first two red lines. So this is a prediction with very small uncertainty. It's quite a good prediction. There's a 95% chance that the shadow will be between the outer two red lines. That's the 2 sigma line. So this is a fairly good prediction. But let me bring up a map of a prediction that has a less certainty to it. Let's see here. Okay, here's maybe Briggs here. Okay, I'll show you this. Now here's a case where the shadow is expected to be the size between the two blue lines, but you can see that there's the 66% window of likelihood goes from between the two red lines. And so there's much less chance that you will be able to see this if you pick, any spot in there, because for this we are not as certain where the shadow is going to go. There's 2 reasons for that. One is we might not be as certain, might not be very certain where the asteroid is, and we also might not be certain where the star is. And so the uncertainty in the location of the star is multiplied by the uncertainty in the location of the asteroid. And that causes these red lines to be much farther away. And so in a case like this, you would be less likely to see this event if you went out in the field or if it was passing somewhere over your house, because the shadow could actually be anywhere within many hundreds and hundreds of kilometers and less likely. So let me show you another one that's even worse. Yeah, so here's a case where you see the uncertainty is so large that it's essentially the entire North American continent. Now you would do one of these just for the science, just in case you got lucky, But in this case, there's very little knowledge about actually where this object is. It's a trans-Newtonian object, and it's quite uncertain as to where the actual Kuiper Belt object is located. So essentially, you would do this just with your fingers crossed, with no hope of ever seeing it, but maybe get lucky. I hope that helps.
Yeah. So yes, of course. And so a question comes to mind, and it's been asked by one of the viewers here, is that does the curvature of the Earth come into play when you're reconstructing the shape of the asteroid from your occultation studies? And factor that in.
It does a little bit, similar to when a solar eclipse happens. If the shadow of the moon is passing right over the center of the Earth, it's pretty round. But if it's passing near one of the limbs or the poles, it gets stretched out into an ellipse. And the same thing is true for the asteroid shadows. If they are not at the point directly, the geocentric point directly under the line between the asteroid and the star, then the shadow of the asteroid is stretched out in one direction or another, and so more users would be able to be likely to see it if it was farther away. But typically, we're not talking about an uncertainty, between like Arizona and the North Pole. We want the uncertainty to be very small. So typically, the answer is no. There's not much change in the shape depending on where it goes. It's usually pretty close to the spot where you are.
Great. So I think there are lots of people who would like to get into this field and start their observations. So they are asking questions related directly to your experience of the observation. So one question is that how can you, if you have a very simple setup, not an automated one, and how can you manually position your telescope and point the camera to the exact point where the occultation will happen? So,
okay. The best way to do that is something we call pre-pointing, and I'll give you an example of how that would work. All right, now I'm going to share the screen here. This is a program called Guide. Guide is a program that many people are able to get. It's a free download, and it's a star map program. In this case, the target star for this occultation is this star here. It's magnitude 14, and I don't know if you can see that little dot right there. That is the target star. Right there for the occultation, and it will occur at 10:47:30. Well, actually, this was from last night, so it occurred at 10:47:30. So if you pointed your telescope at this little star, and you were able to keep it there, and you could find that tiny star, which is magnitude 14, so it's extremely faint. You would be able to record the occultation, but it's very difficult to find a magnitude 14 star because there are millions and millions of them in the sky, and so the guide program provides you with this blue line that shows you where to point your telescope earlier in the sky, earlier in the evening. So if we go off to the right here. Here, for example, let's see, right here. Okay, so here is a star which is magnitude 7, and it's next to a star that's magnitude 8, and it's next to a star that's that's magnitude 15. So here's a very bright star. You could easily find this star, and what this program is telling you is if you point your telescope at this star at 10:26 and maybe 20 seconds, and don't touch it, the Earth will move your telescope, the Earth will turn your telescope, and it will guarantee you that your telescope will be pointing at this little tiny star 20 minutes later. This star will be right in the center of the target star, will be right in the center of your camera at the right time. So there are lots of opportunities earlier in the night. If we go to the right here, you can see there are some really bright stars, like this one, which is magnitude 7. If we go even farther, it turns out that Mebsuta, which is magnitude 3, is another good candidate. Anybody could find Mebsuta in their telescope and just go up half a field and find this little asterism of 3 stars, and you would be in the right place. You would do that about 40 minutes before the event. And in fact, it turns out that the Pleiades is actually along the path here. Let's see, where is it? Yeah, right here. Very lucky tonight. The Pleiades is actually close to this. So 5 hours before the event, you could point your telescope at the Pleiades and then go to sleep. And as long as you woke up and turned on the camera at the right time, you would be able to observe that magnitude 14 star would be drifting through the field of view at the right time. So I recommend this technique to everyone rather than using tracking or trying to get a polar alignment or anything like that, because then you have to depend upon accurate polar alignment and good technology and batteries lasting for 6 or 7 hours. You do it this way, the Earth turns at a perfect rate. It never fails, and you always have success. At least I have found always have success. Except last night, when I did this, as I left the observatory, I bumped my head on the telescope. And it turned out that instead of the star being in the center of the camera field of view, it was all the way down at the bottom among all those numbers, those timestamps. And so we had a really hard time trying to get the timing successfully extracted from there. So don't bump your head on the telescope if you're doing this technique. Don't walk carefully around your telescope and don't touch it. Don't let the wind blow it, etc., and you'll be fine.
Respect your optics. So, and in fact, I would take this chance to encourage everyone in this group. I know you're all serious people. So get your own telescope. That's the first things you should do. If you cannot get one, again, I think the cost is a factor. Go and make your own telescopes. There are ways to make simple reflectors, and reflectors are something I would prescribe rather than, have the
right, absolutely
to make a Cassegrain for example. Okay,
right.
Then it's easy. Ted has just told us an easy way to get the field and just let the Earth's motion do the work for us.
That's the best way. That's the best way, right? And also we have. Let me grab this little adapter here.
Just into the matrix and get some.
Yeah, it's a matrix, right? So we have this. We make this little adapter, which is part of the kit. This allows you to put your camera inside this little tube, and then push this tube down inside the draw tube of your telescope, so that your telescope will come to focus, even if you have a reflector that and you can't turn the focuser in enough to have your camera come to focus in a reflector. You can put this you can put your camera inside this tube and then push the tube down, and you get an extra 3 or 4 inches, and that's enough to allow the camera to come to focus without modifying your telescope at all. And anybody who wants one of these can have one for just the cost of postage. We make these in 3D printing, or you can make it using plumbing parts, PVC plumbing from the hardware store. That we have instructions on our website for doing that as well.
Arvind, you have something to put in?
Yeah, I just wanted to ask you, in this case, you will be removing the eyepiece or camera lens, or both are, it's a focal imaging, or you remove eyepiece as well as lens of the camera?
Yeah, no, we don't use any eyepiece at all.
Okay.
Everything is done completely with the camera. And we always recommend putting a focal reducer on the front of the camera. Okay. It gives you 2 advantages. It makes the field of view wider, so it's easier to find the stars. Yeah. And it also makes the star images smaller and brighter, so that your camera can pick them up. Even if your camera is not very sensitive, if you make the size of the star smaller, they will send more photons into a single pixel, and your camera will pick it up.
Yep.
Excellent. So know your sky, know your equipment, and make changes.
Now, I do have a question here. Can you do this manually without a camera? Yes, absolutely. Before all this camera video stuff, people were making audio recordings by simply saying like out when the star disappears and in when it reappears. And in some cases, if you have the ability to have a shortwave radio with a time station record in the background, just record the like in the United States it's WWV with 1 second time ticks, beep beep beep, and then just have that record playing in the background while you record audio of the disappearance and reappearance of the star. We can extract the time from that from your voice. You can also use a stopwatch. There are also a couple of apps One of them is called Emerald Timestamp for the iPhone, and there's one called Time the Sat for Android. And they allow you to have a screen where you can just tap the screen to start to record the disappearance of the star, and tap the screen again to record the reappearance of the star. And then those are stored for you using not GPS time, but NTP time, which is also fairly accurate, more accurate than just using your voice. But so again, in that case, you would be looking through the eyepiece of the telescope or the binoculars, and you would just be tapping on the screen when you saw the star disappear and reappear. And all we would need to know is the 2 times and your latitude and longitude, and you have made a good contribution to the data.
Yes, sir.
So one of the questions, of the final questions is that if you're finding parameters of an asteroid, is that the only interest of doing occultation observations and studies, or is there anything else that we can get out of these?
I'm sorry, how do you mean?
So the question is that are occultation observations useful? They are definitely useful for characterizing asteroids, but is there any other use for these observations?
Oh, sure. Yes. They, as I mentioned, they're very useful for identifying and characterizing double stars. They were also used in the past to characterize the surface of the moon, and in particular, grazing occultations, where the north pole of the moon, like the north pole of the moon or the south pole of the moon, would have mountains that stick up, right? And there might be a star, and as the moon is passing in front of the star, you would see the star disappear and reappear behind the mountains of the moon on the North Pole or the South Pole. And this allowed the scientists in those days, before the Kaguya and the Lunar Reconnaissance Orbiter, to characterize the geography of the poles, the lunar polar areas. That was the only way to do that, because we can't see those areas directly from here on Earth. So a lot of that, and we still recommend people do lunar occultations of asteroids and of stars, because it's interesting and easy and a good way to get started. And the nice thing about a lunar occultation is the shadow of the moon usually covers most of the Earth, so you don't have to travel anywhere to see a star disappear behind the front edge of the first quarter moon. Every night the moon occults numerous stars, and occasionally it goes through star clusters of bright stars, and then it's fascinating. You can record 20 or 30 occultations in one evening of bright stars, like the Beehive cluster, Precep, or some of those are in the part of the sky near the ecliptic where the moon will actually travel in front of them. So
there are various applications as well, and then the whole world is now interested in asteroids. There was a time when the moon was the target, and Mars was very popular. Now with serials like The Expanse, asteroids have come into the focus, and everybody's looking at them.
Right.
Questions which are asking, when will we mine asteroids, etc. I think that's quite in the future, but right now, at least let's get in touch with the sky and put in some effort to help characterize those. And this is actually a scientific contribution we will be doing. I'll kind of come to bring us to the close of this session. And there's a question about asking about the program itself. So I will first give a chance to Ted, if you want to tell us how to join IOTA. Then I'll tell you how to join the IOTA program.
Sure. Well, it's easy. IOTA has no official dues or any official membership. You can join the easiest thing to do is simply to join the groups.io chat list and begin to monitor that and ask your questions there. Download the software from the occultations.org website, Occult Watcher, guide, someone asked about guide. Guide is you can obtain guide from a website called projectpluto.com. The Occult Watcher program is convenient, and then the programs that we offer to record the data, one of them is called IOTA Video Capture, also available for free on the occultations.org website. So I would encourage people to simply download the software and begin to play with it, install it, check it out, begin to build your kit if you're going to do video occultations. If you're going to do manual occultations, simply download Occult Watcher, look for some bright events that are near you, and go out and try and find them. You can also use the pre-point technique on your manual telescope. So you would be sitting there at the eyepiece watching the stars drift by, and at the right time, hopefully the star that was going to be occulted would be right in your eyepiece, and you would see it disappear and reappear, and then you would record as best you could those events. But I would start by simply joining the groups.io occultations. Now, if you do join IOTA, there's a small fee. I think it's $15 a year, and that gets you access to the quarterly issues of the Journal of Occultation Astronomy, where all of the peer-reviewed papers are published. That's totally optional. We don't require any membership dues. We're happy for everyone to participate by downloading Occult Watcher, joining the chat group, and beginning to chase these shadows as much as you can.
Great. And yes, and closer to home, if you want to join a group of like-minded people, I think IOTA also has regional groups, including IOTA India. And I'll quickly ask my colleague Thyra Pathak, who's sitting in the other room helping us with the YouTube live casting. Maybe you can say a few words about the IOTA website. Yes. Yes. So thanks, Ted, for telling us about how to join IOTA. And Atharva has also shown the IOTA India website. However, I think there was some problem with showing it on YouTube. So for those few viewers there, the website is iota-india.in. So just go there and you can find the contact details of like-minded people who would also be able to help out if you are interested in occultation observations. So
very good.
That's excellent. And I think I'll also mention to finish this, I'll also mention that we are looking at very dedicated trainings and interactions over the next few months with the IUCA M-Visa program. And those who are serious will have a selection at some point of time. And over the years, we've had several rounds of 3 rounds of these trainings where people have gotten to understand really let's say they're not cutting edge technology, but really more advanced than just watching Jupiter and Saturn's rings through your telescope. So when you're doing that, when you're getting to that level where you want to do more, I think M-Visa is a good program to join and stay with for a long time. I think, contribute anything, you need perseverance. So do that and stay with us for the whole series and afterwards as well. I think it's been a great session with all of you joining us. I can see a lot of smiling faces, which means the session has been enjoyable, and a lot of thank you messages coming on the chats. So I pass them on to the panelists here today. And of course, I also all the viewers who have come online on this nice Sunday morning. We promise you to bring more of experts on this series, and hopefully, since mid-November and mid-December are both meteor specials, there are good meteor showers during that. We'll try to get you some specialists on meteor observations, where again you can actually contribute your data of observations. So and I will again thank Ted to have come online at this time. I know it's really late at night at his place. He's across the world on the other side. We are almost at the antipodes. So
almost, yeah. No problem. My pleasure. Thank you for having me. I appreciate it.
It's a pleasure. And also, I know the whole IOTA team has also supported your efforts and this talk. So thanks to them for pitching in. Thank you very much.
Well,
We'll see you sometime in India whenever you come for some observation here. Welcome.
I hope so. I would love it. Thank you.
Great. Lovely.
Thanks for all the good questions, everybody.
Yes, definitely. All really good questions, and we were happy to take them. In fact, you can still write to us. We have our email ID. If you have any more questions which you come up with later, we'll be happy to pass them on to the speakers. Thank you very much. Thanks, everyone, for being here. And see you again. We'll send you notices about the next talk and hope to see you there. Thank you.
Good night.
Thanks, everyone, for being here. And see you again. We'll send you notices about the next talk and hope to see you there. Thank you.
Good night.